Hello everyone, and welcome to another Tech Tuesday. So today we will be visiting part 4 of our Flappy Birds bot video. Um, so in this video I will be going over how to implement the bot for the Flappy Bird so that it can actually play the game itself. So a few unfortunate things. I wanted to actually run this through a machine learning model to predict what the bird should do next until it actually learns how to play the game fully. Um, but with this processing framework, unfortunately, I found that the libraries that I wanted to use aren't very compatible. So what I have done, but this will only be in the final part, so part 5 in this series, which will either release um, a little bit later this year or the beginning of January, was I rewrote this game in Python. Um, there was nothing weird about that, so I literally just used exactly all the same code we have with a framework called Pygame. So it has basically the same kind of setups. So you can literally just take the code as we have it now and convert it to Python. Um, but the nice thing is they actually have reinforcement libraries that are compatible that we can use. So currently I'm still busy setting up those reinforcement learning patterns, but already rewrote the game, so hopefully that video will be able to come out soon. But anyways, let's get onto this video. So, like I said, today we are just going to be talking about how to create the actual bot that just plays the game itself. So I'll give it a little demonstration of what this looks like. So if we just play the game as it normally was, here we go. You can see we have to click and stuff to get the bird going, and then we can just travel through everything and at some point lose. And the end goal that we want for this video today, basically, I already implemented this. I will be going through what the code is and how I did it. But basically, if we, instead of rendering it as us playing the game, and we rather render it as the bot, and we play it now, then you should see that it actually then plays itself. And the way this is set up, this can actually go on forever and ever. So yeah, the bird will never lose the game, no matter what the difficulty or even speeds of the pipes or the gaps or anything like that. Obviously, if the pipe gaps get smaller than the actual bird's height, then you will lose. But other than that, everything else should pretty much go smoothly, and it will just play the game by itself forever and ever and ever. So yeah, let's jump into the actual coding of this. So first of all, you can see I created a method called FlappyBot, and it actually just takes two arguments, which will be the current position of, let's just play this game so that I can explain this. So this first argument will be the position of the pipes pointing upwards. So it will be just this top coordinates um, for the pipes pointing up. And then our second argument will just be the coordinates of the pipes pointing down. So these ones here. And that is basically the only information we need for our bot to actually detect where to go. And I'll explain why in just a second. So let's first run through. I'm just trying to see if I can't get this console a bit bigger. That's fine. Okay, anyways, let's run through that Flappy Bird bot method. So first thing in the Flappy Bird um, file we created. The only work I added, only changes I made from the previous video was I moved our moving of the bird up and the moving of the bird down into their own separate methods, just so that I can reuse them in the actual bot method. So yeah, the render method still does exactly the same thing. If you press the mouse, the bird moves up, otherwise it moves down. And the Flappy Bot method that we added, like I said, it just takes two arguments, the current pipe y coordinate going up and the y coordinate for the current pipe going down. So what I mean by current pipes is, since these pipes are generated in the same class, there's no single way you can just go pipe dot bottom or top, anything like that, and there are always more than one pipe in that class. So we're just taking each time, as you can see, if they go off screen, we're taking the next pipe's coordinates. That's the coordinates being passed through to the actual FlappyBot method. I'll explain how I did this right after I explain this FlappyBot method. So yep, let's jump into it. So how I made the Flappy bot was I just first of all, the top part of this is just exactly the same as the render method. It only actually draws the bird on the screen and then just detects if it collides with the top of the screen or the bottom of the screen, so that it can just stop the bird's speed. And that's about it. And here I just created some print lines just to show what the actual coordinates of the bird is, and that'll just also give us a little bit of an oversight on where we actually want to have the bird be at the exact moment. So that being in between the two pipes. Alright, so let me first explain what strategy we want to use for this. Okay, I have found out how to enlarge this console. So now I can actually show you guys what we are trying to achieve. So if I play this, and if you just pay attention at the bottom printed section each time, that'll just be the latest printed values for our bottom top pipe and the bird's height. Our strategy is basically, now since we have the top and the bottom coordinates, we just want our bird to always be in between those two coordinates. So that's very simple. If you can see through the console, you can see our bottom is 259, top is whatever it is next, but our bird height will always reach the middle of that. So let's just wait for it to go down a bit. So you'll see now the bird height increases until it actually gets to a spot in between the bottom and the top pipe. So to achieve this is actually also really simple. Getting the bird in between the pipes is the simple part, and then after that you just have to make exemptions for if the bird is actually above the pipe going down, and also exemptions for if the bird is below the pipe going up, like this. So if it's below that pipe, it just moves up, and if it's below the pipe pointing down, it just flows down until it reaches the gap. So yeah, that's simple enough to understand, I think. So let's just get into the code. So literally, this whole section is our whole bot. It's very simple, but it does what it needs to. So how do we do this? So just to get the detection of the bird in between the two pipes, that's pretty easy. So if the bird's height is greater than the pipe pointing downward, so if it's underneath the pipe pointing down, and if the bird height is less than the pipe pointing up, it just has to move up and down. That basically just nullifies the bird's movement so that it can just move in a straight line. So you'll see with the animations, the computer just does this very quickly, so it looks like the bird's actually freaking out. But that's just because it's the computer playing the game, so it's just really quick. Anyways, you'll probably notice that there's a random plus 30 here with the bird height, only for the detection of the top pipe. So this is because our bird's height coordinate is actually the top left corner of the bird. So if we just kept it like that, it'll always overflow with the pipe pointing upwards. To just transpose that position to the bottom, you just add the actual height of the bird, which is 30 pixels. So that's the reason we did that. Otherwise, you'll see if it goes up here, otherwise the bird would have actually been to the corner of the pipe, and then it'll just lose the game. So basically we just transposed that coordinate, and that fixes our problem of the bird colliding with the pipe going up. So other than that, that's just our main part in our if statement. You'll see in our else we only have two more guard clauses. So these being if the bird, the height of the bird, is greater than the pipe pointing down, the bird actually has to move up. So that's simple enough. If the bird is now currently anywhere below the gap or the pipe pointing up, it just moves up. And then our other statement is just the inverse. If the bird's height plus 30, again just to transpose that y coordinate for the bird, is less than the top pipe y. So if it's anywhere from this pipe, this point, up, the bird should just fall down until it reaches this exact statement. So yeah, that's basically the bot. There's really nothing much to this. You'll see with the actual machine learning, it's also really simple. It's a simple game to achieve the like goal of machine learning. It's also just going to take about three arguments our model each time, and through those three arguments it's just going to detect what its output should be. So its output, if it should move up or if it should move down, and it'll do that and lose quite a few times until it gets to a generation where it actually knows when to move up and when to move down. This being with the top pipe and the bottom pipe coordinates, and also where the bird currently is. So it's a real easy algorithm to implement and a real easy model to train. But anyways, for creating just a plain bot to play it, that's also just as simple. So I guess the only tricky part is, because of how the pipes are generated, is just getting the information from the pipes, getting the coordinates from the pipes. That's basically the only tricky part in this. So let me actually go and show you guys that. So creating those coordinates, all I basically did was I created two arrays that just houses the top coordinate and the bottom coordinates for the pipes. And the reason I did the arrays is, again, because on our setup functions, we create a dynamic amount of pipes, so it doesn't necessarily have to be the three that we had. It could be two, it could just be one, it could be five, however many pipes you would want to have be created. So for those two arrays, I just initialize them in our setup method, and then I actually just, for each of the pipes, I go through and then just set the actual bottom and the top coordinates. So for the pipe pointing down, I just used whatever the current coordinate is for it to be rendered, and then again, that would be the top left corner. So I just transposed that to the bottom, and then we have the bottom coordinate. So to do that, I just took the actual pipe and the height that it is, and I just added that together. Then you get that coordinate. And for the actual pipe pointing up, that's easy enough. That's just because it's the top left coordinate, that's just wherever it's rendered. So I used wherever it's rendered, and as simple as that. Now we have the bottom coordinates and the top coordinates on at least on initialization. So a few more tweaks that I had to do now was in our render function that we created last time, where we re-render the pipes in the background. So if they disappear off the side of the screen, we re-render them, and obviously then we just want to update those indexes on our array to reflect those changes. So I just added those exact same calculations here in our collision, or at least our detection for when the pipes go off screen. So once they go off screen, we just reset whatever that index is that went off screen to whatever it should be for the new pipe. So that's what's being done here, and that's all good. That's fine. Now we have an array that keeps updating with our new values, but using them obviously now is not so simple, because how do you know which index basically to grab from that pipe? Basically, which index is currently the one going towards the bird, the closest one going towards the bird. So you'll see I have a current index variable on the pipes. So explaining that's also pretty easy. So the current index would just mean that is the current index of the pipe closest to the bird, or moving towards the bird, that is the closest pipe. So in order to actually get that up, we have all our functionality already set up for that. So that's pretty simple. You will see here in the render method, okay, so our current index just gets set to 0 in the setup function, because obviously the first pipe going towards the bird will be 0. It will always start like that. And in our render function, you'll see here where we do the again the part of the collision detection where the actual like pipes move off screen. We added a piece of code that updates the game score. So once the game score updates, we just update the index as well. And just to make sure that our index doesn't go out of bounds, currently I just hard-coded 3, but again, this can just be the pipe count, so you can just swap that out with whatever the pipe count is and it'll work the exact same. But what's happening here is, so every time the pipe goes off screen or the bird passes the pipe, the index goes up and up and up. And obviously, in our case, we set it up to have 3 pipes. So once it gets to that index 3 and it tries to send that data through to our birds, it will be an out of bounds issue. So our array would not have an index of 3. So we just basically want to reset our indexes to 0 every time it hits that out of bounds issue. So to do this, I just used a simple modular check. So if the index mod by 3 is 0, that means if it can divide by 3, it's and it equals to 0, we just reset our index back to 0, and that'll update every single time you move past a pipe. And that's basically all for the current index. So to get this working, I just basically replaced now our self-playing with this new method that we created. And in this method, I just call the pipes class. I get that array of pipe tops, and I just send through the current index, which would be the closest pipe going towards our bird. And the same goes for the bottom pipes. Now, since this is drawn each frame, once that pipe actually goes off screen, dies out, and gets updated with our index gets updated on that exact frame. The bot method will actually get that new data now passed through. So this will be very up to date each time, and it will just you know work very nicely. So again, now if you play the game, you'll see bird's heights currently in between. Now it just went up a bit, but it'll always just stay between these values. It'll always just detect how to get between the bottom and the top pipe. And as you saw, it was a really simple logic check that we actually added for that. But yeah, I just wanted to just quickly set up a bot like this for you guys, since the actual machine learning one failed on this specific framework. But no need to worry, that will still come out. It's just going to be in Python, so at that point I will not really be explaining any of the code for the game logic and all of that stuff, since it will be exactly the same as we currently have. So like a minor few tweaks would be the way the game is drawn and rendered, since the Pygame framework also just handles a lot of that stuff for you. And yeah, then it's that's a lot of stuff code will just be unnecessary to use. But again, it's going to be very simple, and there will be a GitHub repo if you want to go ahead and study this, as well as this work for the bot. If you guys want to download and play around with it, it will be in the GitHub repo linked in the description. So feel free to check that out. But yeah, next time we will actually have the Python game running. And I have to say the animations and the actual movement of the birds a lot smoother with the Python game, since its rendering actually gets handled a lot nicer than on this. Because well, on here you actually have to really focus on how you render everything, whereas the Pygame framework is specifically made for making games, so it's a lot easier as well. But you'll see that when we get to that point. So yeah, thank you guys for actually joining us on this video today. It was a little bit short, but hopefully, again, you guys found it just a little bit interesting. Basically, just found it interesting how simple it is to implement something like a bot playing the game itself. And then again, next time when we get to the actual machine learning, hopefully you guys will feel the same about that as well. It's how simple it really actually is to implement all of that yourself, or at least using the proper libraries. Because if you want to create machine like model trainers and all of that stuff from scratch, it'll be quite a bit more complex and take a lot more time. So yeah, anyways, thank you guys for joining us, and have a great rest of your day.